reward shaping is the new hot programming language. This is a controversial statement. It's actually coming from a couple of people in the software industry, so I want to paraphrase them. And it's also, this is a reaction to Andrej Karpathy's presentation he gave at the AI startup school in San Francisco recently, where he spoke about his most recent tweet about vibe coding and his 2023 tweet about English being the hot programming language. So it's not really a critique. I think it's a further development, and it's in the same spirit. I have a high respect for Karpathy as an industry observer and really a person that has this unbelievable ability to reflect on the industry and give us outsiders, meaning people who aren't embedded in the software engineering community, a good sense for where things are going. So having said that, what do I mean with reward shaping is the new software language? Well, first, it does assume that there's a paradigm shift in the way we develop digital infrastructure, and the paradigm shift starts from, let's say, how it was before 2012, and now it's evolving into a new direction. So the big directional shift was 2012 with AlexNet and the birth of Software 2.0, which is that the composition of data which is fed into an algorithm develops the weights, which are the software, which then develop agents that solve problems. So that's Software 2.0, and we've been riding on that for the last decades and change. I think what's new now is that we're getting into two types of realms. One is the large language model realm, which is that now we're actually shaping the algorithm itself that is developed, that is delivering the problem-solving capabilities. So we have sort of the two steps. We still have the training through data, but because they're general trained models like GPT, we are now sort of pre-training a vast amount of potential action spaces. So we're storing a vast amount of knowledge, internet scale knowledge, in computer readable data. In other words, in some sort of vector latent space, and then we can query that latent space, and that's what English as a hot language means. We can use English as a prompt to then query that space and get solutions. And those solutions start very simple right now with questions. Like most of us use, whether GPT or one of the other models. I use a lot of Grok. It's how can I go hiking in Switzerland? What do you suggest? How do I do, like things like that, right? But of course, this is just the beginning. We're in the process now of developing an agentic infrastructure, which is that we're using these LLMs as operating systems for navigating that latent space and giving us solutions. What I want to talk about here now is the next level, and I guess this should be done Software 4.0, which is reward shaping, and that implies that we're using an adaptive model such as reinforcement learning. Reinforcement learning is the go-to model for the types of AI that require instant adaptation to the environment and very flexible interpretation of that latent space. So that's, I guess that's probably the best way to summarize this particular epoch that we're in. This is not even on podcast. It's June 19, 2025. This is Krim Delco. For the year, we are down 16.8%. The market's up 1.6%. We're on by 18.4%. Just before I start, we are in Zurich now, so we're traveling, some private travel, but always interesting to go around the world and see new things, even though, of course, Zurich is not new for us. I am from Zurich, and I go here quite a lot, but it's interesting to to get a little bit of a perspective of what is going on elsewhere in the world. And I think here at Orange Capital Partners, the purpose of this podcast is to give people a sense for what it feels like to run a hedge fund. And we talk a lot about reading books, we talk a lot about traveling, we talk a lot about, you know, trying to understand what is going on and trying to rewire our frame of reference. I think that's very important for the hedge fund business. This is just a sort of a tangent to this particular episode. Let me dive into the presentation. It's in the show notes, the link. So Andrej Karpathy gave a presentation at the AI Startup School, and he talked about the importance of large language models, and he most importantly, he classified them. He put them in order. He put them in a place where we have a better understanding for their function. So let me give a little bit of history here. So the birth of software as we know it goes back to Alan Turing and the von Neumann compute architecture. And it's very deterministic in a sense that you give a machine instructions, and the instructions get executed on a gate-driven model circuit. Later on, we called it an integrated circuit, an IC. And with the birth of the transistor and the integrated circuit, we had the revolution that drove us from the 1950s all the way to 2012. I think that evolution was relatively sort of incremental and on one path, which was deterministic. It just became more flexible. It became more scalable. It went from central to decentral to back to central, mainframe, personal, back to cloud. But it was always deterministic in a sense that we always had to write code and software engineering in a sense that whatever we wrote, whatever code was written was also executed in a very deterministic way. The evaluations were very straightforward. Unit tests were very straightforward. We also had very little flexibility. If we look sort of an arch of maybe the amount of flexibility that our software systems had in terms of adapting to the environment were very limited, but most importantly also the application space was very limited because you had to software was limited to deterministic actions such as, for example, banking transactions or things like immigration, classifying people where they live, like a lot of that type of stuff. Walmart grew in that realm as a sort of massive database for inventory. Then we had Amazon, which took it to the next level, but kind of is the same thing. So modern retail was enabled. Modern banking was enabled, although banking didn't particularly change as much as we think, because it was still fundamentally the same thing. It just became a lot more efficient. But a lot of these types of, I call it deterministic transactional services were digitized. After 2012, we are changing direction. We're going from software 1.0 to software 2.0. And software 2.0 is that you are now developing algorithms that classify data inputs into a system of weights, and the weights are the software. So the weights determine the output and not the actual algorithm. So the algorithm is sort of, if you will, like a filter that takes in the data and filters that data into a set of weights that then develop actions. And that's software 2.0. That is the sort of birth of what we today call AI, or the big breakthrough in neural nets. The reason Geoffrey Hinton got the Nobel Prize last year, the reason we had this huge breakthrough in AI-driven applications, such as, for example, now self-driving cars. We can do photo recommendations on the iPhone. We can do recommendations on Netflix. We can classify customers based on their usage, and also, very importantly, what distinguishes these systems from the systems of software 1.0 from an application perspective is that the software 2.0 systems were adapting to the environment. So that's kind of where we were until 2023, because that's when GPT-3 was launched and the revolution of large language models sort of upended Silicon Valley once again. Now, what's software 3.0, which is the coinage that Karpathy used? He also used another term, vibe coding, which is kind of similar. Software 3.0, excuse me. Software 3.0 now is basically English language used as a prompt, which then develops software and writes and then executes. Now, what does that mean if we go a little bit deeper into the architecture? So we said software 2.0 was we write an algorithm, we write it typically in Python. That is, I like the uses of a filter, which literally is a common filter. For example, is a very simple software 2.0 technology, but of course we have much more sophisticated filters. Jensen Huang calls it function approximators. Think of it like you have a sort of think of it like a maybe a net. You're a fisherman, you're going out there and you have a certain net that is supposed to catch certain types of fish, and the net is the algorithm and the fish is the data that comes through that net, and then the result is whatever you catch. Maybe that analogy helps. So this is software 2.0. What software 3.0 now does is it actually helps us change the algorithm. It helps us change the algorithm according to our needs. In other words, large language models are an accumulation of potential action spaces, or in other words, an accumulation of potential nets or filters. So that's why it's called general pre-trained, right? We just pre-train that thing, and ideally, if we had unlimited amount of compute power, we could potentially store all possible actions that are known to human mankind in a latent space, and then call that general pre-trained, and then use English prompts to prompt the model. In other words, then to look for that part of that huge generally pre-trained action space to pick that net that we need for whatever software problem we want to solve. So what that means in plain English is that we can use English as a programming language, and that has huge implications for vibe coding is just one of them. But what it does, of course, is it democratizes software development. Now, as hedge fund managers, we're typically not so much interested in social aspects of technological development. We are, of course, but that's not our primary goal. Our primary goal is to try to understand the evolution of industries and the evolution of enterprises and companies and wealth creation. That's what we're trying to understand. So what democratization typically means is, and this might sound a little bit paradox, but it also means a bifurcation, which is a paradox in itself. Democracy leads to bifurcation of winners and let's call it neutrals. I don't want to call them losers, but there's a few people who will most likely reap most of the benefits here. And that's just the nature of democracy. The same way you have in any Western liberal democracy, you have much more, how should I say this? You have a certain amount of people who accumulate massive amounts of wealth, and then the rest has a certain amount of wealth, but certainly not massive amounts of wealth. So inequality goes up, and that's because it's kind of a winner takes it all model. That's what democracy typically does, as opposed to socialism that tries to stratify this a little bit more, diversify this, and then of course there's issues with that in terms of political, problems and those sort of things. But that's not the topic of this podcast. What I just want to say is that from an industry perspective, what we most likely will see is that we'll see certain companies taking a massive amount of wealth for themselves. And we as managers, we always, we look very carefully onto the PQ model here, which is, we want to see that. We actually want to see companies succeeding in generating massive amounts of wealth. What we also want to see, of course, is that the wealth that they accumulate is proportional to the wealth they create for society. And as long as that's, sort of P over Q is above 10, so the wealth you create for society is 10 times or more than what you create for yourself. As long as that is given, we believe that society will tolerate that, and therefore we can continue investing in those types of companies. A good example would be NVIDIA, which has generated a massive amount of wealth and is being tolerated because the amount of wealth that they're creating for the rest of society is still much larger than the wealth they're creating for themselves. The reason we believe that is, you just do the math. If you can, let's say, improve US productivity by 10%, you're generating roughly $3 trillion in productivity gains per year. And that, of course, is roughly the market cap of NVIDIA. So if you give it a 10 times sales, give it a, something like that. So the wealth creation for society is at least 10x, if not more, than what NVIDIA is worth right now. So having said that, now let's talk about Software 4.0, which is the actual. So what is Software 4.0? Software 4.0 relies on reward shaping for reinforcement learning models. So what do I mean with that? First, what are reinforcement learning models? So the difference between reinforcement learning models and, let's say, typical, let's say, what's the difference between vibe coding and reinforcement learning models? Well, think about it this way. Like, vibe coding is human intelligence that is trying to adapt to a certain problem and is using English language to translate that into a large language model, or maybe in the future into a multimodal model, and therefore enables that multimodal model to access its latent space and hopefully deliver a solution. Reinforcement learning does the same thing, but it does it sort of in an automated way. So it uses its own model weights, its own learned model weights to adapt flexibly to an environment. And reward shaping is sort of the optimization function that allows that to happen. So in other words, with reward shaping, we're trying to automate what vibe coding does with human intelligence. That's, I think, in a nutshell, the way we see the way we see Software 4.0. Now, what that means is, particularly for robotics, in our opinion, that is actually the solution to robotics. And therefore, we consider reward shaping the programming language for robotics. Because if you just look at software development, you could imagine, at least in the short run, a world where human intelligence drives the sort of evolution of software development. But in robotics, that cannot happen. You cannot have people walking behind robots, and you need an automated model that dynamically adapts the robot weights to the environment, which is what reinforcement learning actually does. So that's, in a nutshell, what we wanted to say here is we see this, let's say, in the realm of self-driving cars, which is, of course, our focus with Tesla. What we're most excited about here is the ability to do this in simulation, and therefore have sort of a mu zero type approach, or an AlphaGo zero type approach, where we do self-play and self-learning based on simulated environments. Now, this probably warrants its own episode. Hopefully we can do this just as adjacent to this one, because we sort of see this as a two two levels of development. One is software 4.0, the other is the ability to generate worlds and therefore have reinforcement learning applied in virtual space or in the omniverse, if you will, to use Jensen's or NVIDIA's language. But I guess to summarize, the flexibility in adapting to the environments is driven by the models that we use and the data that we have available. And reinforcement learning is depends on, of course, the data which we can have through interaction with the environment. And the reward shaping is the programming language that shapes the optimization of the weights that are necessary for the intelligence to adapt to the environment. Thank you.